Today is Tuesday, and we are going to continue with systems of equations by looking at some special cases today. So I have two examples that if you've printed out the guided notes and you have a color copier or color printer, you will have color-coded ones. My printer is not color, so I colored them in, but they should correspond with the same colors that are on your paper. So what we're going to do is we are going to solve some systems of equations, and we're going to see some strange things happen. Okay? In the first one, this one's just typical, just like the ones we've seen before. We've got two lines, we're going to graph them. They're crossing at a point, and we can identify that point as our solution. So these are crossing at the point 0 and 1. We can tell that that's the solution because if we plug 0 in for x and 1 in for y into both equations, it would work. Let's say I plugged it into this one. Y is 1, x is 0. 1 equals 0 plus 1, that's true. If we plug it into this one, we would have 0 plus 1 equals 1, and that's also true. So we can always verify answers just by taking those x and y values and plugging them in. Let's say we didn't have a graph, and we wanted to solve this system of equations, and we didn't have any visualization. We could solve it algebraically using either substitution or elimination. Remember, substitution just means that if you've got a variable alone, you would just take all the stuff that's equal to that variable and plug it in right here. We could do elimination, but it would take one extra step here. So we always want to pick the easiest thing. So whatever makes the most sense for the system that you're looking at. For this particular system, if I didn't have a graph, I would probably use substitution just because I have a variable alone. Or if you really like Desmos or you're really strong in graphing, you would just graph them and find your solution. For anybody that just needs a quick refresher on the algebraic method, I'll show you this one with substitution, but we already have our answer, so it's not like we need to do it. So let's look. If y equals x plus 1, I'm just going to rewrite this equation. So it's going to be x plus what used to be a y equals 1. In place of the y, I'm just going to put its equivalent, which is x plus 1. We're left with an equation with one variable, so we can solve. There's nothing to distribute, so I'm going to combine like terms. I'm going to subtract the 1 from both sides and divide by 2. We have x equals 0. That's only the beginning, but we need the y value that goes with it. So we can take that 0 and plug it into either one of those equations. I kind of like the top one. And I would have y equals 0 plus 1, so y equals 1. Your answer will always be written as an ordered pair, x comma y, which we already had right here. So again, we just did that just to refresh the algebraic methods because we already have the solution. So that one's typical, but this next problem is a little bit different. So let's look at what happens in this. These two lines are already graphed for us. If you notice, they are parallel. They are never ever going to cross. So when we're looking for solutions to systems of equations and we say that it's where the two lines are crossing on the coordinate plane, but they're never going to cross here, that means we have no solution. It's just never going to happen. They're never going to be equal to each other. So graphically we can see that, right? It makes sense. These things are parallel. Their slopes are the same. They're going up 1 over 1, up 1 over 1. This one's going up 1 over 1, up 1 over 1. So they have equal slopes. They will never cross. Let's say I wanted to do that algebraically. So let's say substitution, right? We've got a variable alone. We might as well use substitution. So if y is equal to all of this stuff, what we would do is rewrite the bottom equation. And I'm just going to leave the y blank. So x minus what used to be a y equals 1. In place of the y, I'm going to put x plus 4. Now I'm just going to solve. We do need to distribute. We've got a negative sign. So take the negative sign, make sure it goes into the parentheses. That becomes x minus 4. Just changes those signs. We're going to combine like terms. X minus x, though, look what happens there. Cancels. And we have negative 4 equals 1. This is a false statement. All of our variables canceled, and we end up with something that's not true. So because this is a false statement, that means that no matter what I plugged in for x and y, it was never going to work, which is why there's no solution. So variables cancel out, you're left with a false statement. There is no solution to that problem. So on a graph, it's because they're never going to touch. They have equal slopes. Algebraically, it's when the variables cancel and you have a false statement. We also could have seen this prior to algebraically solving or graphing. If you get really good and you practice these a lot, if I had solved these both for y, we would end up with this one, which is just y equals x plus 4. And then let's just say that I solved this for y, so I can add the y over and subtract the 1. We have this. So if we had looked at these, we would see, oh, the slopes are exactly the same. Those are parallel lines, but they have different intercepts, which means they're parallel lines that are far away from each other in the coordinate plane. They're never going to cross. So just lots of reasons or lots of ways we can check this. So I would encourage you to first do it algebraically and then use Desmos or graph paper to check your solution to see if it made sense. So today we're either going to have one solution that we can identify the x and y values, or we're going to have a pair of parallel lines that will never cross and there's no solution. So on this next page we have 4 examples. I'm going to do 2 of them with you and 2 of them you're going to do on your own. So let's look at the first one. We need to decide what method makes the most sense for us. Even though elimination is my favorite method, I think substitution makes sense here because we've got y equals and y equals. We can also see that the slopes are not the same. So these are not parallel lines, which means they are going to cross. So I'm going to set up substitution, and I'm going to set these 2 things equal to each other because they're both equal to y. So we're going to have 2x plus 1 equals x plus 3. Now I just need to solve this equation for x. I'm going to start by moving this x to the other side. I'm just going to subtract it. I have x plus 1 equals 3. So I just need to subtract the 1 to the other side. Okay, I have my first coordinate, or my first variable, but I'm not done. I also need the y value so I can set up the coordinate. We can plug it into either one of these equations. It's completely up to you, just whichever one looks the easiest. I like this one. So I'm going to plug that in, and it'll be y equals my x value plus 3. So I have y equals 5. That makes my ordered pair 2, 5. So this one does have a solution. The lines are not parallel. Their slopes were not the same, so I knew they had to cross, and that is where they cross. You could plug in this x value and this y value into both equations and find out if it's true if you wanted to check your work. Or you could plot it on Desmos to see that they're crossing at 2, 5. Let's look at the next one. We have y equals x minus 5, and then we've got an equation that does not have a variable alone, and it's x minus y equals 3. Even though I love elimination, I'm going to go substitution here again. I have y alone in this equation, so I can take all that stuff and plug it in for y right here. So I'm going to rewrite that equation as x minus what used to be a y equals 3. And in place of the y, we're going to put x minus 5. Now to solve, be careful, we've got this negative sign here, so we need to make sure to distribute the negative into the parentheses. So we'll have minus x and then plus 5 equals 3. Combine like terms, and you'll notice something weird happens. We've got 1x minus 1x. Those cancel. I'm left with 5 equals 3. Now, this is a false statement. So my variables canceled out, and I was left with a false statement, which means there is no solution. So if I were to graph these on a coordinate plane, they would be parallel. I could also solve for y and look at the slopes and see if they were parallel. What I want to do right now is plot both of these on Desmos so we can check our answers. So we're going to plot the first one. My Desmos canceled. Okay, So let's take a look at the computer. We are going to plot the first problem. So y equals 2x plus 1 is my first equation. My second equation was y equals x plus 3. Okay, so we can see that they're definitely crossing. We can hover over it, and there's that 2, 5. So just checking our work that we did algebraically, we found that they do cross. So now let's check the second problem. Second one was y equals x minus 5. And my second equation was x minus y equals 3. So we can definitely verify that there's no solution. These have the same slope. They're never going to cross. Okay, so we checked our answers to numbers 1 and 2. So at this point, you guys can hit pause and you can attempt the next problems on your own. And you can hit play when you're ready for the solutions.